Welcome, Simon. We're really glad to have you join us again as the guest speaker for session 5. A amazing introduction for Simon. He has been a long-time contributor to Django. He has been contributing to ORM for more than a decade and is an amazing community member. He has served on the Django 5.x steering council and is also part of the security team and the triage and review team. He has a background in software engineering and also works as the principal backend engineer at Zapier. So there's a lot of awesome stuff that he builds, that he does. And to give a little sneak peek into that, he's here with us today to share about the talk, Django, What the Join. Such a cool title. We are super excited to deep dive into it and learn how the ORM turns relational references within the join. Welcome, Simon. Over to you.
Thank you, Priya, and thank you for having me a second time. I'm really happy to be here. So before diving into the subject, a bit of a small introduction. I'm based in Montreal, and for the rest. So if you ever pass by Montreal and you want to discuss Django stuff, let me know. Hit me up on GitHub or my email. I'd be happy to discuss it with you. So before diving into the deep of the subject, deep into the subject in terms of how the ORM turns reference to different models into actual SQL join. I think it's worth spending a bit of time understanding what a join is. So as you know, the ORM allows you to map Python classes to tables in relational database systems, such as SQLite, Postgres, and so on. So these systems allow you to define entities which have some property represented by columns, and each row represents an instance of your entity. And the strength of these systems is that, just like in the real world, you're able to relate these relationship together. So that's a way to kind of like model the world, model data around it. And in this space, a join is a way to combine data. So if you have data from one side, for example, author and books on the other side, a join instruct the relational database and how to project the data, how you'd like to combine the data, do a form of intersection between both. So you can think of a way as having matching records between two tables combined together, and there are a few ways to do that. There are several types of joins. The ones that are going to be of interest to us and the ones that are the most common are an inner join. So an inner join is, and we'll go into more details about that with examples, but it is a strict intersection between two data sets. If you have a data set, a table inside A and another table inside B, you try to combine them, then only data that is present in both will be present in the inner join. And outer join is subtly different. So it will include the strict intersection, but for parts that are not in the intersection, the database will provide null values for that. These joins are preceded by a left and outer, a left or a right specifier. And the reason for it is that it determines which side of the relationship, so on the left, so A or B, left-hand side or right-hand side, should have the null values. If this is confusing to you, now we'll go a bit into more details on that subject. So let's look at this very simplified representation of a book in a publisher. So in this case, we have a book model which has a relationship to a publisher, and this relationship is nullable. If we are to create a publisher and we are to create book, in this case, we would be creating one book that is associated with the publisher that we just created, and the other one that is not. So just a way to model the fact that there might be some independent book that are released. In this case, if you were to be using inner join, as I mentioned previously, only matching records between two tables involved in either the publisher and the author would be returned. And if there is no match, then no row would appear. So if we were to do an inner join between the book table backing the book model and the publisher model, publisher table backing the publisher model, and we were to join between both of them, well, we know that in the case of one of our book, it has no publisher. So when we try to intersect it with the publisher table, there cannot be an intersection between both data sets. So in this case, the rule would be excluded. If we were to do a left outer join, the difference, as I mentioned previously, would be that we would get this strict intersection. So by intersection, I mean the intersection on the specifier for the join. So in this case, you can see publisher ID equals book publisher ID. This is what determines what the intersection should be on. A left outer join, which will return the strict intersection and will also return rows on the left. So in this case, the table that is on the left of the join is the book one that has no publisher. And for the rows that have no publisher, it will set null in there to represent that it's outside of the intersection. So if we were to do a left outer join, so very exact same query, but instead of using an inner join, we use a left outer join, we would get a different data set being returned by the database. We would get a published book, an independent book, and everything, all the columns that relate to the publisher table that we join would be null. So a small summary of it, the inner join is the strict intersection between both tables, and an outer is the strict intersection plus. And this plus uses null to represent the lack of intersection between both tables. So when does the ORM span joins exactly? Well, you might be familiar with the under syntax between fields. So if you use method like filter or exclude, you could be doing something like give me all the books that have an author which name starts with Simon, for example, or something like that. You could be using select related as well to refer to relationship. And another case as well, which doesn't include the under syntax, also known as the double underscore syntax, are reverse relationships. So when you define a foreign key through the Django ORM, you're able to specify a related name. And when you do that, since the relationship is not defined in the model, it will still span join because it needs to kind of like join back to the table where the field was defined. And so that's when joins are spun. And in order to understand which kind of join is used, it is important to understand why one should be picked over the other. So as we saw previously, the accuracy of the results is affected by the kind of joins that you're going to be using, right? Just by changing the join type, we've got a different set of results. And you can imagine that as more model get involved, more table get involved, and the set of results that you would get, depending on the type of join, would greatly differ between both. The second one is that there are some cases, and we'll look into them into more details, where one or the other joins could be used interchangeably. Yeah, I think I got that right. But it's still preferable to pick the inner one or the inner over outer. And the reason for it is that when you ask the relational database to evaluate your SQL and turn that into actual code where it fetches data here and there on disk and so on, and combine it together, if you tell it about an inner join, it knows if you use the inner joins of an outer join, it can make some decision with regards to how much memory is going to be required to combine both data sets, because the intersection is likely going to be stricter than what you have on the left side. So it helps even if in some cases you could be using an outer join in the case of an inner join and get the same results, it is preferable to specify explicitly to the database that you want an inner join, because it can make some optimization for it. So that you might have, if you're familiar with SQL, you have heard in the past, like, oh, it's pretty bad if you use like a left outer join, you should be try to use inner join. That's one of the reasons for it. Inner joins are easier to optimize. It's easier for the database to reflect about it and return the results in a faster fashion. Last thing, before we dig more into the rules, into how inner and outer are picked up, is the something we should know about how the SQL null behaves and what it means, basically. So if you're familiar with more Python and you use none for example, and you use other strings, you might be surprised to know that if you compare Python to SQL, if you do something like none equals none in Python, you'll get true, right? Well, in the case of SQL, null is used to represent unknown. So if you do null equals null, you will always get false out of it. And that's something that is very surprising to folks that are not familiar with SQL. But one way that you can think of it is, since null is meant to represent something unknown, if you don't know about something and you don't know about something else, then you can't know that they are equal, right? These are two unknowns. They could be equal or it could be not. So that's one of the mnemonic trick that I use to reflect about that. And that's important for the following, because when you do specifier for joins, for example, inner join publisher on publisher author.publisher ID equals publisher, well, you're using the equal operator. And that means that if none cannot equal none, then in some cases you can take shortcuts in this regard. So the 4 rules that we'll look over in terms of like when does Django picks one join over the other. The first one being that non-nullable relationships are always a good candidate for using inner, because if there's no null value, then in this case, there's no reason to have special null handling. If the relationship is not nullable, so for example, if we knew from the get, if we had defined a data model previously in a way that each author must have a publisher, there's no reason to even use left outer join, because we know that an author can only exist if there's a publisher associated with it. We'll go over all of these rules in more details. The second one is that if you have a nullable relationship, but you're constraining it in a way that removes null from the relationship. So for example, say that you have a author publisher that can be nullable, but you're only interested in author that have a publisher with a specific attribute, then in this case, you can ignore nulls. And in this case, the first rule applies and it becomes a non-nullable relationship. We'll go over all of these rules into details, but this is more like an overview. The third rule is that there's an exception to the second rule, is that there are some functions that behave differently with regard to null. So if you can think of some of them already, you'll have time as well to, I will ask if anyone knows about them. And lastly, there's another rule that if you are doing multiple joins, so if you have a very nested relationship that you need to up with the under syntax through multiple relationship, then the moment you've got an outer join, because it's not eligible for an inner join, everything that comes after must be outer as well. So that was a lot. Let's dig into each of these rules one by one. So the first one, non-nullable relationships are always candidate to be inner. So that is the case for select related, filter, but it is not the case for things like reverse relationship, right? Because in these cases, they are nullable. What I mean by that is that if you look at, again, our author and publisher models from the publisher perspective, since the reference is coming from author to publisher, there's no way from the publisher perspective to know if the data exists on the other side. Hence, it might not exist, hence it is considered nullable. Let's look at a particular model set to understand this a bit better. So got a simplified reservation system here where we've got a first room model and we've got a reservation model that has a room foreign key. And it has a reverse name, a related name called reservation, which means that if you want to refer to reservation from room, you're also able to do so. If we do something like reservation.object.select related room, we are asking the ORM to start from reservation and also fetch all the data that relates to room. And in this case, we know that we cannot define a reservation without a room. Like the field is not nullable. There's no way to create a row with reservation without a room. So in this case, we know that the relationship is not nullable, and we can use an inner join when joining between both. If we do it on the other side, though, so from the room perspective, in the data model that we have, it is possible that you create room and no one has reserved them. So from the room perspective, the relationship is nullable. So if you start from room and you go to reservation, like it's the case here, you need to use a left outer join, because otherwise you would be excluding room that don't have any reservation in the data set, and that might not be something you're expecting. So that's the first rule. The second rule is that if you have a nullable relationship, so for example, the second one that we looked at, that was going from room to reservation, you can have a room without reservation, but you are applying a filter that specifies that you are only interested in some reservation, so some reservation between a date, for example, then the moment you do that, because you're only interested in a subset of the relationship becomes not nullable. Because if you are interested in only the room with reservation in 2026, for example, well, all the ones that don't have reservation at all, they're not candidate. Hence, the join can be, even if the relationship is nullable, can be turned from a left outer join to an inner join. And that because null, as we saw previously, does not equal anything. Null does not even equal itself. And when that's the case, the first rule applies. So let's look into this with an example again to understand it a bit better. Here I've got the similar data model that we had previously, where we've got an author that relates to a publisher, and the relationship is null. So it is nullable. If we are to do something like author.objects.filter, and we are only interested in the author that have a publisher name equals foo, then normally, because the relationship is nullable, you would have to use a left outer join. But since you're only interested in author that have a publisher, because if they don't have a publisher, they can't have a publisher that have a certain name, then in this case, you can turn the left outer join to a null. So if the filter that you're applying are constraining nulls, like we see here, it promotes relationship, you can use an inner join, and it's easier for the database to reflect about it. So I alluded to that previously, but there's a slight exception to it. It's not all the filter that you pass to the filter method that will restrict a nullable relationship. So I'm curious to hear, maybe Mr. Priya, if people can raise their hand or just speak, but can anyone come up with an exception to the rule that does special null handling when you call into filter?
Make a guess. Are you asking about like the case when expressions? Is that maybe one of them?
You could have one expression that do it, but there's even kind of like finer grain ones. So maybe one more guess, if someone like a lookup or a function that deals with null in a special way.
Is it the in expression?
In does some specialized handling with it, right? Yes, but it's not in this case. But yes, it does something special, because if you have in null, you need to specialize special cases. But yeah, that's a good one. All right, I'm going to move forward, but these were kind of like two good example. So the one I am referring to is the one like the is null lookup, right? So if you are partially interested in something that is null, then it's very important that the null are not removed from the expression, that you don't go from a left outer joins to an inner joins that remove null. There are some other functions that the framework provides, such as coalesce. If you're not familiar with coalesce, it's kind of similar to the MySQL if null function. You can pass it multiple arguments, and it will return the first one that is not nullable. So it is very important that if you do a filter by that, well, the framework does not make an optimization that change the semantic of the query by removing null from the equation. So let's look at this exception in detail. If we compare to what we had previously, it's the same data model with the author having a nullable relationship to publisher. If we do something like publisher equals name foo and publisher or publisher name is null, then in this case, it's pretty important that we don't do an inner join against publisher, because otherwise it would elide or remove all the author without publisher from the equation, and we could not apply the where. So the framework is smart enough to see these things even in very nested queue objects and say, okay, no, you know what? I cannot make this optimization here. It's important that null are not removed from the equation. There is unfortunately bugs on this front that exist that we are aware of, but not sure if you've played with it, but it is possible nowadays to use lookups directly. So semantically, these two queries should be equivalent. So here you see that we do q publisher name is null true. In this case, we specify it using the lookup instance directly. So if we create a lookup is null and we pass it like that, so we refer to the field and we set it to true. Unfortunately, the ORM is not aware of that, and the reason for it is that the reason why the first case work is that the is null string lookup check is hard coded in the ORM. It's not something that is a property of expression that denotes kind of like a flag that tells the ORM, you know what, I'm special with regards to null. But yeah, this is in the process of being fixed. We talked about it with Jacob, the fellow at Django on Demand last week. So the last rule now, if you do joins against an outer join table, even if you're normally admissible with the previous rules for an inner join, you must stick to iter. And this will become apparent why in the example, but it is mandatory to preserve null values. And the reason is that if you have something that has null values and you need to preserve them, for example, author with publisher being potentially null, and you go one step further and you try to do an inner join with null values on your left-hand side, as we know, null does not equal anything. So augmenting the join chain would remove result from the previous join. So let's look at an example to understand that a bit better. If we have author, publisher, nullable, but now we add another model, location. Obviously, this thing would have like details and so on about what it is. It's not important for the sake of this example. But publisher now has a foreign key to location, which is, I'll point it out, not nullable in this case. If we do a publisher.object.select related location, well, we know that from the publisher relationship to location, the relationship is not nullable, right? You cannot create a publisher without a location. It is hard-coded in our data model here. We don't set it as null true. Well, in this case, we are able to use an inner join. So all fine on this front. Things change though when you start the relationship from the author side. So if you start from author, you go through publisher, then you want to go to location. Well, now your publisher relationship has become nullable because in that transitively or it applies to further joins by the end. So what was previously an inner join from publisher to location now becomes a left outer join between both, because now publisher is a nullable relationship because it's coming, it's originating from author where it is defined as nullable. So these are the four rules. There's some optimization around it as well. And it's a lot to kind of like wrap your heads around all these things. Hopefully, if you are curious about how these things are being put in place, I would suggest you have a look at these two methods on the SQL query method, one that relates to setup join and join. The first one being the logic that turns the string that you're used to, that is relationship underscore underscore other relationship underscore underscore field into an actual join data structure. And the second one performs join reuse, which is the last area I'd like to cover. So what join reuse is exactly. As you when you build a query set, you're going to be passing it around, right? And in some cases, you're going to be calling filter on it, you're going to get a new query set, you're going to be passing it around in another location. And if Django was creating join every time a new filter call is made, or every time the same relationship is reference and reference all over again, well, database wouldn't be happy about that, right? Because it would need to do unnecessary work, I mean, the database, but also you as some person potentially that needs to maintain this database and build fast application will also not be happy about it. So there's some logic in the RM to perform join reuse, and there are some rules to determine if a join can be reused between filter calls. The first one is that if you make multiple reference to the relationship in the same query set method calls, for example, select related, filter, or annotate, then the join will necessarily be reused. If you are targeting, and the other rule as well is if you are calling multiple methods, but they're all targeting single valued relationship, then it is eligible. So to explain what a single value relationship is, if you're not familiar with the one-to-many or one-to-one or zero-to-one way, it's just a way to say like, how does this model relates to this one? Can this publisher have many books? So it's a multi-value relationship. Or can an author have only a single publisher? Or can a publisher have a single location? So it determines like, is the relationship, does the relationship has up to one value or up to many value? But we'll look into example as well to explain that a bit more. So back to our set of models that we add, augmented it now with two more fields, being the author name and the DOB for date of birth. Obviously, this is an oversimplified representation of the world, but it should serve us well for the purpose of this demonstration. So if we are to make a single query set method call in this case, and we are targeting a multi-valued relationship, what I mean by that again, by multi-relationship, is that from the publisher perspective, a publisher can have many authors, right? It's the reverse relationship of a one-to-many. So from the publisher perspective, there are many of them. If you make a single filter call and you ask for, give me all the authors that have their name that start with Simon and their date of birth is somewhere around that time, then in this case, Django will use a single join. And you will notice here that even if it's nullable, since we are making a filter that restrain or exclude null values, we are using an inner join. But the important part here is that there's a single join. If you do to make two distinct filter call, it will result in two different joins. And the reason is that for multi-valued relationship, there is a nuance between what exactly you mean when you target it. So when you target multi-value relationship, you could be interested in two things. For example, in this case, are you interested in all the publisher that have at least one author that both have its name that starts with Simon and has its date of birth year in 1987? Or are you interested in the publisher that have at least one author that starts with Simon and another author that starts with that has their date of birth year in 1987? So there's a bit of nuance between both, right? Are you interested in one member of the relationship that matches all the criteria, or are you interested in publisher that have at least one author that match one or the other? And the way Django allows you to specify one or the other is through multiple filter call. This is very confusing to folks coming to the RM. It is kind of constraining sometimes as well, because you want to pass query set around, but you'd like to reuse a join that was previously used. Unfortunately, the RM today does not allow you to specify that you'd like some joins to be sticky, or you'd like to say like, hey, you know what, I'd like to be able to reuse the join if it already exists. It might come in the future, but today that's how things work. So for multi-value relationship, if you make one or two distinct filter call, it will result in potentially multiple joins being issued. It is not the case though with single valued relationships. So in our data model, an author can only have a single publisher. So even if we make distinct filter call, since they're all intersection over the other, and they can refer to only one element relating to the author, the ORM is going to be using a single join and systematically reusing it across annotate, filter. If you were to add 20 more of them, it would still do the same. So yeah, so the rules are basically, if you have a single value relationship, then the join will be reused. If it is a multi-value relationship, then depending on if you refer to it multiple times in the same method, query set method call, or if you do it in multiple, then you will end up with a different behavior. So that was a lot. Hopefully that was useful. I will go through like a small summary of what we just saw. So first thing, we looked at what a join is. The second one was a small explanation between what an inner and an outer join is. The second one was explaining the semantic around null, the kind of like weird behavior with the fact that it does not equal anything, and thus it's used to represent unknown. And if you don't know about two unknown, then in this case, well, you cannot take a decision with regards to are they equal or not. Third one was around the inner versus outer rules. Relationship are nullable. Is the nullable relationship constrained the null function, null and link functions such as is null and coalesced, and the second one being the transitive property of outer joins. And last one, the ORM join reused for single value relationships. So hopefully these provides you tools, make the ORM a bit less intimidating. Obviously there was a lot there squeezed in a very small amount of time. So yeah, I'm happy to answer further questions that you might have.
Thanks, Simon. That was such an insightful and well-curated, in-depth content. Thanks a lot. So yes, we're open for questions. I can see the first question from Eddie regarding how to ignore none during compilation phase. Eddie, would you like to go first and ask the question, or shall I read it? Okay, I think I was okay. I'll go to the question in the chat. Okay, that's totally fine. I would like to know more about ignoring none during compilation phase. In qs.exclude foo __ in is equal to none case, I still get none values in the objects retrieved from the DB. Is ignoring none still a relevant approach to deal with the conversation into SQL, or is there a better suggestion about it?
Yeah, so I know there's a ticket open about it. I'd like to kind of like refresh my my context around it. My understanding is that SQL, because of how weird SQL is with regards to null values, and the best effort that the ORM makes in trying to make it less weird when you pass, or almost transparent when you pass none in any specifier. So for example, when you do exact none, it will turn it into is null without you having to do anything. There is some, if I remember correctly, the moment that you have a none value in a nin lookup, it will always be unknown because it cannot be certain and so on. So in terms of, is it the right way to fix it? I would have to look more about the ticket. I'm not sure that ignoring none is the best way to do it. I feel like in some cases, one thing we could do is if we see that we are passing a literal list that contains some value, something we could do is turn it into a, remove the non-null values and add a or field is null or something like that, try to add it further. But yeah, I would have to look a bit into it. I know that there's been a discussion as well where there's an SQL function called any, which behaves very similarly to the in lookup, but treats none slightly differently. So maybe that could be an avenue as well. But yeah, you might be using exist as well if you're passing subquery, because all the best effort that Django will do with regards to passing in a particular list, it won't be able to do if you pass in subquery, because when that happens, well, it's not a literal set of values. So Django has no control over whether or not the subquery can be itself returning none and throwing the result away. So hopefully that was useful. But yeah.
Thanks. Next question we have is from Tim. Tim, would you like to go?
Yeah, I think it's going to be similar, related to Emma's question following this as well. But it's around use the term sticky for filters when you have a many-to-many field and you do multiple filter calls. I know you said we don't support that. Are you aware of any discussions from the past about trying to implement support for it?
Yeah, so there are a few tickets about it. The fact is the ORM itself makes a lot of use to it internally. The reason is that if you have a related manager, so for example, so that you have a publisher instance, to go back to our model, and you do something like publisher.books.all, well, the query that is specified there is going to have a filter of the form, well, give me all the book, like looking back the reverse relationship. And what Django has done over time is that the first filter call that you make, so if you were to do like publisher.books.filter, will be sticky to the internal filter that was applied internally. So to allow you to hook into that and avoid doing multiple joins. Yeah, the ORM uses it internally. I believe that the best way forward there is to allow for relationships to be explicitly marked as sticky. What I mean by that is that today, relationship between models can only be defined declaratively, so they need to be on the model itself. I believe that there's a way to expand on what we have with filtered relation, and have something that is more similar to what we get in, I think it's called Django relativity or Django relative. It basically allows you to define relations, and I think that the best way to go forward with that would be to allow these relations to be defined through the alias method. So you'd be basically able to say, I want to, so from the publisher perspective, you could do something like publisher.objects.alias author sticky or author reused, and you would just pass a relation that is authors and sticky true or reused true or something like that, because I don't think we can reasonably change backward compatibility on this front.
So I just want to follow up on that. I had a colleague actually implement a second filter method on the query set model that was called sFilter, which just hacked in like setting sticky equals true and allowed us to basically squash all those filter calls together. So like, yeah, just pointing that out in case anybody else finds it helpful.
It is technically doable. Like it's the TLDRs, if you look into like these setup join and join method, they all take a query called reuse, and you can pass any table alias that the query knows about in there, and it will use them. It's just that, yeah, in this case of distinct filter call, we don't do so. I think there's even a query nowadays which is reuse all or something like that. So it might make your sFilter things even easier to implement.
Neat. Cool. Thank you.
Thank you. The next up we have from Emma. Emma asks, I have some memory of, yeah, please, Emma, go ahead.
Yeah, I have some memory of many-to-many relationship where there was one filter on the right-hand side of the many-to-many that, despite being in the same filter call with multiple filters in there, resulted in basically an OR statement. So filtering multiple times on multiple joins. Is that still a thing? Or maybe I'm just misremembering and there was just multiple dot filter calls, but I feel like it was all in one and the result was quite unexpected. Is there something to know about many-to-many in regards to just simple joins between two tables? Because many-to-many are joins between three tables instead of two.
Yeah. I have two leads maybe that relates to that. The first one being that if you do a negation against a multi-value relationship, the ORM would perform what it calls a subquery pushdown. So instead of trying to get the right semantic with regards to null and ling and so on, it will basically take what should be a join, turn it into a subquery, turn it into an exist over it, and do the specialized null handling on top of it. Because otherwise it becomes very hard to reason about null handling because you're negating something and then the other joins wouldn't need to take care of that. So that might be one thing. So even if you have in the same filter call, and if we take our previous example where we're doing publisher.object.filter, or I think it was author.filter.publisher names equals something, or publisher other property. If you were to negate one of the component on the OR, then the subquery pushdown would happen in this case. So maybe that's what you're referring to with multiple join. It is surprising to a few people that if you use like a negated multi-value relationship, it turns into a subquery pushdown and a join if you are referring the relationship in another mean. So that might be it. The second one is that today the ORM, there's one optimization that it does not do. Even if you have database constraints that are put in place from a, say if you have a many relationship between author and books, so books can have multiple authors and authors can have multiple books, then the intermediary table is always going to be joined against. Well, in some cases, for some queries, you can basically pop through it, right? You don't always need to have it. So there are some cases where because of the way the relationship is defined, we do opt through joins that we could potentially remove. So we could avoid joining through a table and use avoid using the intermediary table. So that might be another thing where there's an extra join. But yeah, it's hard for me to tell which case you're pointing to. So hopefully that relates to it slightly.
Yes, it was something like, so an author can have many books and a book can have many author, and we're filtering on books with author name like Simon and author name like Charette. And
Okay.
it was doing the join twice, and so returning both users with Simon and Charette. And I'm pretty sure it was in the same dot filter, but maybe I'm misremembering.
Okay. Yeah, it would. I know for sure that in the case of a two filter call, it will have this behavior. Maybe there's some cases in a single one, but I'm not aware of them.
Okay, thank you. Do we have any more questions? Anyone? Okay, then I think we're all clear and happy with today's session. Thank you so much, Simon, for joining us today. It means a lot to have you with us. Thank you. Thank you, everyone, for your valuable time as well.
Thank you, everyone.